Video is about the multiple choice question from the chapter Atomic Structure. First is cathode rays are deflected by electric field only, magnetic field only, electric and magnetic field, none of these. So we have two characteristics of cathode rays given over there, that the cathode rays consist of negatively charged particles. When cathode rays are subjected to an electric field, these are deflected towards the positive charge plate, that is anode. Also, when the cathode rays are placed in a strong magnetic field, these are deflected. So the option C is the correct answer, that is the electric and magnetic field. The E by m value of the particle constituting the cathode rays is same regardless of the gas present in cathode ray tube, the metal of which the cathode was made, the metal of which the anode was made, and all of the above. The value of E by m remain the same irrespective of the nature of the gas used in the experiment. Also, the cathode rays are electron that will not depend upon the material of the electrodes, because the nature of the electron will remain the same regardless of the electrode as well as the nature of the gas. So the answer D is the correct answer, that it will not depend upon the nature of the gas as well as the electrode material. The charge to mass ratio of the positive particles, that are the canal rays, it varies with the nature of the gas in discharge tube, is independent of the gas in discharge tube, is constant, and none of the above. The E by m of the positive particle depends on the nature of the gas taken inside the discharge tube, because the positive particles are ions of gas molecule whose charge and mass vary in accordance with their mass and charge they obtain, which mean that the positive ion differ for each for each gas. So the answer A is the correct answer. There are two MCQs. One is related to the cathode rays, or we can say the negative charge particles, and the other one is the positive particles or the canal rays positive particles. In cathode rays, the nature of the cathode rays or the negative electrons, it will not depend upon the gas that is present inside the tube, while in case of canal rays or the positive particle, the E by m ratio will depend upon the nature of the gas. So for canal rays, it will depend upon the nature of the gas, while for cathode rays, it will not depend upon the nature of the gas. A subatomic particle which has 1 unit mass and 1 unit positive charge is known as hydrogen atom, neutron, electron, and proton. So a proton carrying single positive charge that has a mass of approximately 1 unit mass. So the proton is the correct answer. The atomic number of the element is equal to the number of dash inside the nucleus. We know that the atomic number is equal to the number of proton inside the nucleus. The mass number of the atom is equal to the number of dash inside the nucleus of the atom: proton, neutron, electron, nucleons. So we know that the electrons are outside the nucleus, and proton and neutrons are inside the nucleus, and nucleons. What is mean by the nucleons? Nucleon is the one of the particles of the atomic nucleus, or we can say the proton and neutrons together are termed as nucleons. So nucleons are the particles that are present inside the nucleus, and we know that the mass number is equal to the sum of neutron and proton. So nucleon is the sum of neutron and proton. So nucleon is the correct answer. If Z is the number of proton and A is the number of nucleons, which mean the mass number or the sum of proton and neutrons, then the number of neutron is in the atom is equal to, we know that the mass number is equal to number of proton plus number of neutrons. Rearranging it, neutron is equal to mass number minus atomic number, that is the number of protons. So A minus Z is the equal to the number of neutrons. B is the correct answer. The mass number and the atomic number of phosphorus atom are 31 and 15 respectively. The number of neutron in the nucleus is 15, 16, 31, 46. So the mass number, it is equal to the number of proton plus number of neutrons, and the number of neutron is equal to the mass number minus atomic number, that is the number of protons. It will result in 16. So 16 is the correct answer. In a sodium atom, atomic number is equal to 11 and the mass number is equal to 23. The number of neutron is. So first we will find the number of neutron using this formula. Then we will be able to calculate the number of neutron that is equal to the number of proton, that is less than the number of proton, or that is greater than the number of protons. So first we will find the number of neutrons, that is equal to the mass number minus atomic number. So 23 is the mass number and 11 is atomic number. It will result in 12. So 12 is greater than atomic number, that is equal to 11, and that is equal to the number of protons. So the number of proton is 11 and the number of neutron is 12. So it is greater than the number of protons. Which one of the following relation is not correct? Here 4 relationships are given. So first we will find their corrected value of these relationship. So option A is correct because the correct value is lambda over frequency. So lambda multiplied by frequency, so it is correct option. Wave number is equal to 1 over lambda, so this is also given. Wave number is equal to 1 over lambda, it is also correct. Frequency is equal to C over lambda. So if we rearrange this formula, lambda is equal to C over frequency, or C divided by frequency. So the option D is also the correct option. Wave number, frequency is equal to wave velocity of light and wave number. And if we look at the option B, here these are inversely related, and in corrected value it is directly related. So option B is incorrect option. In the spectrum of hydrogen atom, the series which fall in the ultraviolet region is Lyman series, Balmer series, Paschen series, and Brackett series. So here is some information given that a Lyman series, the lowest energy level is 1, while the higher levels are 2, 3, 4, and so on. And this series lies in the ultraviolet region. Similarly, some other series are given, that is the Balmer, Paschen, Brackett, and Fund series. The lower level are 2, 3, 4, and 5 respectively. Only the Balmer series lies in the visible region, while the other 3 series lies in the infrared region. So the question is about the ultraviolet region, and we will find the series. So the series which will fall in the ultraviolet region is Lyman series. In the Balmer series of the spectrum of hydrogen atom fall in ultraviolet region, visible region, infrared region, none of the above. So these two questions are related to this table. In question 11, the series is region is given, and the series we will find the series, while in question 12 the series is given and we will be directed to find the region. So the Balmer series will lie in the visible region. Lyman series is obtained when the electron from the higher energy levels return to first orbit, second orbit, third orbit, and fourth orbit. A similar question is given, in which in question 13 there is a series given and we will find the orbit, while in question 14 the number of orbit is given and we will find the series. So a line in dash series is obtained when the electron from the higher energy level return to n is equal to 4, n4. Lyman series, Balmer series, Paschen series, and bracket series. So we will use the previous information in which the Lyman series, the lowest energy level is 1 while the higher level are 2, 3, 4 and so on. So the lowest energy level for Lyman series is 1. So it will return from the higher energy level to n is equal to 1, that is the first orbit. So the first orbit is the correct answer for Lyman series. For question number 14, it will return to n is equal to 4. What will be the series? If we look at this, here the lower level is 4 and that is the bracket series. If we look at this diagram, the lower energy level n is equal to 4 and the series is bracket series. So the answer is bracket series, in which the electron from the higher energy level return to n is equal to 4. The energy of photon is given by the relationship. Here are four relationships are given and the energy of photon is equal to the hc over lambda. So this is the correct relationship according to the energy of photon.